Here we see an object move across the screen at constant velocity. A common technique for studying the motion of objects is to use multiple flash photography. We can allow the computer to simulate a periodically flashing strobe. The resulting photograph that is obtained shows images that are equally spaced, indicating that the object is traveling equal distances in equal time intervals. Instead of flash photography, we are going to allow the computer to place a dot periodically at the position of the ball, here every half second. The equal spacing of the dots again indicates that the object is traveling at constant velocity. For an object traveling at half the original speed, the trace would look like this. The dots are more closely spaced, indicating the slower velocity. For an object that accelerates from rest, the trace looks like this, where the dots are originally close together and then get further apart as the object travels faster and faster, indicating that it is accelerating. We will frequently use this technique to record the motion of our objects. Let's look now at the equations we will be using on this tape. We examine an object undergoing constant acceleration along the x-axis. If we imagine the object at 2 points along its path, at an earlier position and a later position, at the earlier position, we arbitrarily assign the time at that point to be equal to 0. T0, the 0 standing for the original time is equal to 0. At that point, the displacement is x0, referred back to the origin of our coordinate system, and the velocity we label v0. The object undergoes a constant acceleration in the x direction. Sometime t later, it has a displacement x, and it has a final velocity v. The relationships that we are interested in are, first of all, the definition of acceleration, that acceleration is equal to the final velocity minus the initial velocity over the elapsed time. Secondly, that the final velocity squared minus the initial velocity squared is equal to 2 times the acceleration multiplied by the final displacement minus the initial displacement. The third equation, that the final displacement is equal to the initial displacement plus the initial velocity times the time plus 1/2 the acceleration multiplied by the time squared. It would be a good idea to write these equations down on a 3x5 card so that they will be handy when we solve our problems. Let us look now then at our first problem.